Good morning, grade 1S students. I hope you are doing well. Today I'm going to start a new chapter, chapter 7, electric receivers. Please open your copybooks and write some notes. In the previous chapter, we saw the electric generators, and we said that these are electric components that convert the chemical energy into electrical energy. They supply the circuit with current. What about electric receivers? From its name, an electric receiver receives electrical energy and converts it into another form of energy. It could be chemical, mechanical, or thermal energy in the form of heat. Some examples of electric receivers are electric motor, heater, telephone, razor, and electrolytic cell. So, electric receivers are electric components that convert the electrical energy into another form of energy. I will give you here some examples. For example, the electric motor converts a part of the electrical energy into mechanical energy characterized by rapid rotation. Another one is the electrical heater, which converts the whole electrical energy into joule energy, for example, heat and radiations. The electric razor transforms the electrical energy into mechanical energy, shaving. And the last one, the electrolytic cell, converts the electrical energy into chemical energy characterized by the redox reactions. To determine the current voltage characteristic of a receiver, we set up the following circuit containing an adjustable voltage source G, which is the generator, a protective resistance Rp to limit the value of the current and to protect the circuit, a switch, and an electrolytic cell with carbon electrodes containing an aqueous solution of sodium chloride. Then we measured the voltage UAB across the electrolytic cell and the current I flowing in it for a series of increasing values of the voltage supplied by the source G. The results of these measurements are noted in this table. We notice that the current remains zero as long as the voltage across UAB is less than 2.6 volts. For example, when the voltage is 0.5, the current is zero. As we increase the voltage to 2.55, the current remains zero. And that as the current increases, UAB also increases. When the voltage is greater than 2.6 or 2.75, here we notice that there is an increase in the current. Then I plot the graph of the voltage across UAB as a function of the current on a convenient scale. This graph is called the current voltage characteristic curve of the electrolytic cell, as shown in this figure. The characteristic curve is a straight line segment, not passing through the origin because it is not passing O, and whose slope is positive. Why is the slope positive? Because the line is ascending. Can you see the line? It is a straight line. So any receiver whose characteristic curve is a straight line segment is called a linear receiver. Now let's write the line equation of a receiver. The equation of any line is represented by y equals ax plus b. Instead of y, write the variable UAB, and instead of x, write the current. It becomes UAB equals a prime I plus b prime, where both a prime and b prime are two constants. I presented a and b with prime, a prime, b prime to differentiate them from those of the generator. On the graph, how do we calculate the slope? By putting this formula, u2 minus u1 divided by I2 minus I1. The slope should be greater than 0 because the line is ascending. What about b prime? What do we call b prime? B prime represents the voltage across the receiver when the current is equal to 0. This constant is called the back electromotive force, represented by E prime. Conclusion, now I can write the equation as UAB equals A prime I plus E prime. The back electromotive force varies from one cell to another. This is a characteristic value of a receiver. Note, the back electromotive force, or E prime, is expressed in volts. From the figure, E prime is equal to 2.6 volts. Do you remember the statement of Ohm's law? The voltage across the resistor is directly proportional to the current traversing it. So the formula of any resistor is U equals Ri, and the formula of a receiver is UAB equals A prime I plus E prime. By a simple comparison of these two formulas, I can conclude that the slope is equal to the resistance. So R prime is the internal resistance of a receiver, which is another characteristic of this electric component. So the two characteristics of electric receivers are the back electromotive force E prime and the internal resistance R prime. The final formula and the equation of a receiver is represented by UAB equals R prime I plus E prime. This relation shows that for I different from 0, the voltage across the receiver is always greater than its BEMF, or the back electromotive force. Today's session is finished. Please review the lesson.